Hi, my name is Laurin, and I'm here today to talk about going from private to public GraphQL API. Of course, it stopped working. Okay, here we go. So about me a bit. So I'm a software engineer at the Guild. So I have a GraphQL consulting background, and I've been building a lot of GraphQL open source tools over the years. So one of those is GraphQL Yoga. It's a JavaScript server that you can use. It's like batteries included. There's a lot of plugins. So whether you want to use persistent operation, analytics, stuff like that, comes with it built in. And then another popular tool that you probably heard of from us is GraphQL CodeGen, which is a tool for giving you a type-safe end-to-end experience, whether it's for the client or the server. And from there, we evolved into building an open source GraphQL management platform, which is called Hive Console. And this one basically helps you evolve your GraphQL schema, gives you insights in how your GraphQL schema is being used when you deploy it to production. And then also it helps you prevent breaking your schema clients when you evolve your schema over time. Yeah, you can integrate it in your CI, CD systems, get feedback on GitHub, and so on. And yeah, it's basically a tool that helps you to integrate, that you can integrate in your development workflow to ship GraphQL with confidence. So okay, it's also open source. You can just visit it. Everything I'm talking about today, you can just look at the code. It's not just me talking about it. And so why do I even talk about it? So the thing is, Hive Console is a GraphQL platform that is actually built with GraphQL. There's something going on. I guess we recovered. Okay, so today I want to talk about how we use GraphQL for building Hive Console and how we made our private GraphQL API that we have there public. So I have 4 things I want to talk. First, how do we even use GraphQL while building this? Then, why we even decided to build a public GraphQL API? How we managed transforming our GraphQL API that we already had into a public API, and last, how we even protect this API from evil intents. So our stack is quite complicated. There's a lot of things going on. It's just an overview. I don't want to go into everything there. What's important for the purpose of this talk is how we use GraphQL for building Hive Console. So if you look at our stack from the GraphQL perspective, you can roughly divide it into 3 parts. We have the dashboard, we have a CLI, and we have a GraphQL API. Both the dashboard and the CLI are sending GraphQL requests to the GraphQL API, and the dashboard is using persistent operations, and the CLI is getting there, but we're not there yet. So for the GraphQL API, it's built with Node.js TypeScript, and we use a schema-first SDL approach. And we're using our own libraries that we built, GraphQL modules, GraphQL CodeGen, and GraphQL Yoga for building that API. So how do we develop our GraphQL schema? So we use the SDL-first schema development flow. That means we always start with first writing our SDL. Then we use GraphQL CodeGen to generate GraphQL resolvers. And then we write our business logic and connect it with the GraphQL schema. If you want to learn more about this, there was actually a great talk today about this from my colleague, Eddie. If you didn't see the talk, check out the recording for sure. So then we have the dashboard, which is basically the front end for our GraphQL API. So it's a TypeScript web app using Vue.js. We are using Urkel as our GraphQL client. And there we also use GraphQL code generator with the client preset. And on top of that, also persistent documents. So this from the new GraphQL org website. It's really cool. So we use the data co-location pattern there. So within our code base, we use GraphQL fragments for defining data dependencies for our components. And then we compose them into a single query to have a nice experience. We love that. This is actually a code snippet from our code. So we use the GraphQL function. We write our fragment. We run CodeGen. And then we get types. We write our components like this. And it allows you just to write super scalable components. Yeah, there was a talk also about this today. So if you missed that, check it out as well. So the last component is the CLI. Also Node.js TypeScript. We're using Oakcliff, which is like the library for writing CLIs. And there we don't use a specific GraphQL client. We just do like HTTP calls that we type with GraphQL CodeGen. As I said, in the future we also want to use their persistent operations, but we're getting there. Yeah, and also type safe through GraphQL CodeGen. So persistent documents. I mentioned it before. And we're using it to secure the traffic or like reduce the traffic from our web app to our GraphQL API. Persistent documents basically means at build time of your application, you extract all the documents, hash them, and embed them on the backend or like the GraphQL API. So then the app only actually sends the hash to the API. The API can look up the actual operation that we want to execute. And if it's there, we execute it. If it's not, we tell you, nope, you can't execute that. So why do we want to use persistent documents? Well, the reason is that in GraphQL, everyone can execute any GraphQL operations, even a malicious actor, and just by reducing the amount of operations that can be executed, we disallow other people from like abusing the fact that we have a GraphQL API. Okay, last thing is, how do we prevent breaking changes? So you can remove fields from a GraphQL schema, but it could still be used in one of your clients. So if we remove a field, like how can we prevent that the client suddenly gets like an error message or whatever? Well, one way to solve this is to never break the schema, but in theory that could work, but in reality and with working with our clients that never works really. So there is a need to change the schema. So for Hive console, we have a mono repository. So all the server code, all the client code is actually co-located. And we could check the integrity of the stack statically just by looking at a certain commit in the GraphQL, in the Git repository, which tools like GraphQL Code Generator or GraphQL Inspector can do. But actually we have a CLI, and the CLI has like many different versions. And different versions of the CLI use different GraphQL operations, and the GraphQL operations evolve over time. So just by looking at the latest CLI version that is in our Git repository, we cannot say, hey, this GraphQL schema change would break the CLI version from 2 years ago that someone pinned in their project and never upgraded. So what we actually do is, when a client sends a GraphQL operation to our GraphQL API, we analyze the GraphQL operation and extract the schema coordinates that are being used in there. And then from there, we can have breaking change detection. So based on our real traffic, what we do is gather the analytics. And then when we do a schema change, we get our overview of which operations are broken or which operations by which client would be affected by doing a certain schema change. And then we can basically see who is using our GraphQL API in which way, and who do we need to contact in order to do that. Yes. So last, for this part, I want to also talk about why we even choose GraphQL over REST, gRPC, gRPC, or whatever. So yes, we only have 2 clients and we only have 2 clients for our GraphQL API right now. But in our experience, just using GraphQL gave us a way superior developer experience compared to all the other things that I just mentioned. Whether it's the type-safe schema, only fetching what you want, or the advanced patterns that you can build on top of these GraphQL patterns like reusable UI components or GraphQL clients giving you optimistic UI and automatic updates and a normalized cache. So on top of that, we are also a GraphQL consultancy in the past. So we are GraphQL experts. We worked for it with a long time. And for us, this also gave us the opportunity to use our own tools that we built for our clients, for our own product. And from there, we could even improve our libraries. So in our experience, like many GraphQL users are still only scratching the surface of what's possible. And I'm happy that we're here today, everyone, and showcasing these advanced GraphQL patterns in order to like make all the people, whatever, in which stage of GraphQL adoption they are, aware of that and show them what cool things they can do with GraphQL. Okay, so now I talked a lot about how we use GraphQL. Next, I want to talk about why we even decided that we want to have a public GraphQL API. So, and I want to start this story, this part with a short story about an unexpected breaking change. So I was working on the GraphQL API and the dashboard, something like this. I was just adjusting a view that we have in our application for like showing you statistics about how your GraphQL schema is being used. And I was doing some breaking changes because we're deploying the API and the dashboard together. So for us, it's OK to do the breaking change. And then I did that, and I saw, hey, there's other clients being affected by that breaking change. And so I looked into that. And I cannot show the company's name here, but literally someone was sending GraphQL operations to our API. And because we monitor our product with itself, it showed up there. So I was like, what the fuck? Like, people started reverse engineering our API. Yeah, we disable introspection, but jokes on us. Like, the GraphQL schema is on GitHub because it's an open source project. So they figured that out, and they started using our API with the CLI access token that was never actually meant to be used for a generic API access token. So yeah, people started using our private GraphQL API. And then also other clients started filling gaps that we did not have, like a Terraform provider that is also using the GraphQL API and operations that we had in our CLI. And on top of that, also parts of our private GraphQL schema. So we realized we actually need like a public API to satisfy the needs of those customers, because the CLI wasn't just enough for them. We wanted to like give them something they can work with safely and that is sustainable for them, and nothing that we would accidentally break because we did not realize they were using it, even though we actually already had the tools for realizing when we would break someone, which was quite cool. So we came up with like some requirements that we need for them. So a lot of people wanted to manage like users and access tokens on our platform, and also just query data that we had there for our dashboards, and they wanted to integrate it in their own products. And then also we have the CLI that you can use for like publishing GraphQL schemas to the schema registry. They wanted to do this as part of their own CLIs that they use specifically within their company, because they already had some specific flows that they were using. Yeah, so we wanted to give them an option to achieve that. So we very quickly decided that we actually want to reuse our existing GraphQL API for doing that. For several reasons, we have a not very small, but quite small team, and just now building another API and then having to maintain both our internal GraphQL schema and another schema just felt like something we did not really want to do. We were using a GraphQL monolith, like, yeah, we were not using federation at that point. And on top of that, our customers were actually like GraphQL users, because we're building a product for GraphQL. So they use GraphQL every day. So if we would give them a GraphQL API, they would, at least to some extent, be already familiar with using GraphQL. And as I said before, we already kind of had the tool for evolving a GraphQL API, specifically for like monitoring how the API is used, and then the breaking change detection. Okay, so we decided to build a public API. So how we made actually the API that we now had into that public API. So we decided we will go dual schema. So the private schema that we had, that we already used within the dashboard and CLI, at some point in the future we already planned that it will be fully locked down and only be accessible with persistent documents. And we were 50% there with the dashboard. We just did not do it yet for the CLI, because we had like older CLI versions that were still being used, and we were waiting and introducing gradually like persistent documents to the CLI. Then we also wanted to have the public schema, which is a subset of the private GraphQL schema that is meant for third-party customers, where we feel comfortable with the schema that it's stable enough for giving to someone and where we wouldn't just do unexpected changes that would break them. So we decided to achieve this like schema duality with GraphQL Federation or like Apollo Federation. If you didn't figure out, like you can almost transform any GraphQL schema into a subgraph just by adding this to the GraphQL schema on the top. And then we were using federation contracts for actually filtering down the schema. So this is a very basic example of a public field that we tag with the name public. And then we create a schema contract that only contains fields that are tagged with public, and boom, we have our schema filtering. That basically, this is actually from our GraphQL schema. This basically allowed us to, over time, add parts of our GraphQL schema from the private schema to the public schema as we refactored it, and were comfortable with exposing it to other people. So we actually implemented this schema filtering and composition as our own open source library. So if you want to check that out, go for it. So another problem that we have was identity and access management. So we had the CLI users, we had dashboard users, and we had the GraphQL API. Now we also had third-party users. And in order to understand our struggles here, I have to give you a very quick rundown of the resource hierarchy. So we have an organization within Hive, and then you have like projects. Projects is basically a GraphQL API, and the target is like a deployment stage, like for example, development, production, quality analysis, and so on. And we already had these access tokens for the CLI because you publish your schema to the target. But now what people wanted is like, we also want to manage projects and organizations and everything in between. And then they also wanted to only allow managing specific projects and targets, and maybe only the organization, and only allow read access to the users in the project, and so on. So our old approach on how we did authentication there was not up to that. It was very simple. So we need to go to something, transition into something more complex based on policy statements, which we eventually did. But then we realized that some of the parts of our GraphQL schema are not view agnostic. And what does that even mean? Like, we had fields in our GraphQL schema that were at the moment only usable by CLI clients because they had business logic hard-coded in there that asserted whether you're in a CLI session, and then we had a specific way on how we access resources based on the access token. In the old access token, even like the project's organization and target were hard-coded to the access tokens. So we needed to fully rework our access layer, so we have this abstraction of whether you're an organization member or an access token member, and we translate that into policy statements. And that required schema modifications because we could no longer retrieve the resources from the access tokens that we want to access in a mutation, but instead they need to be provided as input parameters. So it required a lot of adjustments in how we use our schema, and then as we reworked the permission layer, we had then a generic abstraction for verifying session access within our business logic that we call in our GraphQL mutation resolvers. So on top of that, we also wanted to do some cosmetic GraphQL schema changes in order to follow just some best practices, clean up some past mess, and we just wanted to have like something consistent and future-proof that is as extensible as possible for us. So we came up with an internal schema design document that I set up, and then people started commenting, we started discussions, and from there we came up with something that everyone feels comfortable with and that we can use as a reference as we start refactoring the GraphQL schema. And I want to highlight some stuff here because the topic is like very subjective, like every team could have other preferences on how they want to design their GraphQL schema. I think the most important part is that it's consistent across the team. So one thing is the cursor connection pagination, which is a superior way of like doing GraphQL pagination. Basically, yeah, we had different parts, different ways of doing pagination over the years, and everything we added to the public GraphQL schema, we made sure that it follows this. There's also a talk about this from Michael. Should check it out. And then the next thing, or the last thing that I want to highlight about schema design is the error states that we came up with our own pattern. So just by looking at this GraphQL schema, we cannot really see what could be the error state of trying to create a project. So yeah, because GraphQL errors are not type safe, there's a lot of talks about that. You can check these out. So what you can do is model the GraphQL error, the error state as part of your GraphQL schema, which is also something we already did, similar to this. But over the years, like using this approach, we did not like this type name selection for like discriminating stuff. So we came up with our own style. So yeah, this is how you get type-safe results. Like you look up the __ type name field, or you do like structural checks of how the object is being constructed. If you're an advanced user or use like an advanced GraphQL client, maybe that's easier, but like if you're just getting used to GraphQL, that might feel a bit weird, and to me, the __ always feels weird. I alias the field sometimes. But yeah, we have oneOf for input types recently added to the GraphQL spec, and we actually already used oneOf for our mutation results. So instead of using a union type for modeling our result types, we use the oneOf thing, and that basically means instead of like doing the type name lookup, we can just check if OK or error is within our object, and based on that, then do whatever we want to do with the mutation result. Yeah, there's one exception that we still have for like authorization errors, because we don't think it makes a lot of sense to model them as part of the GraphQL schema, because you just messed up setting the permissions on our UI. So in this case, we just raise something so it escalates more, so people know, okay, we need to adjust actually something with the access token. Okay. So last thing I want to talk about is how we protect the GraphQL API that we then designed. So as you all know, GraphQL has some overhead. Whether it's the parsing, validating, or the execution, if you compare it to a REST API, there's a lot of overhead going on there, which basically allows targeted GraphQL attacks. So all of these operations, parsing and validating, are CP outbound. And yeah, it's happening before even the execution starts. So before you actually start loading data, there's a lot of things going on. And on top of that, by allowing to execute arbitrary GraphQL documents, this could be potentially abused by a malicious actor that, if he gets through the rate limiting, like sends some fishy GraphQL documents to the API in order to like waste your resources and eventually bring down the GraphQL API. So I have some example here, like maybe a parsing DDoS where you send like a lot of GraphQL documents that are very unique. So what do? Like you exhaust the GraphQL server. At some point, the GraphQL server cannot even use a cache because you send so many different GraphQL documents, and maybe it will even go like completely down at some point. Then another popular thing is like a resolver waterfall. Like you send very, very deeply nested documents that in the best case scenario have like a cyclic relationship with an end-to-end relationship even, if you want. And then also you waste the server's compute time and maybe let it go out of memory or whatever. So that's pretty bad to open a public GraphQL API. So if we're building like a private GraphQL API, I would just say use persistent documents, but in this scenario, we cannot really do that, right? So what can we do instead? And if we look at the GraphQL document, it can be separated into things that are called tokens. So basically everything you see in a GraphQL document is a token. And what we can just do as we parse the document is like keeping track of how many tokens we have parsed. And then if it's like 9,000, we just say, oh no, we don't like that. Let's just abort parsing that and stop parsing that, because it seems like someone is having evil intents. And then another popular approach that people do is like looking at the depth of the GraphQL operation. So this we can only do in the validation step after the parsing. So there we like track how deep we go. And maybe we also track like what's the type of the relationship of like if it's a list field and so on. And then if we reach a certain depth, we just say, oh, this seems quite deep. I'm not sure if we want to execute that. Looks malicious. And then we also just say nope, and we reject the query. And then something that builds on top of that is query complexity analysis. It's basically a hybrid approach of both. So we traverse the document, and based on the fields that are selected and the depth, we calculate a whole score for the GraphQL operation. And if that score exceeds the budget that we defined statically on the server, we just reject it from being executed. Yeah, and the cool thing is with federation, you can even like annotate your GraphQL schema and can say, hey, this field is very, very expensive. So yeah, GraphQL operations that try to query this field recursively will be rejected faster or something like that. Oop. Oh no. Yeah. Another cool thing you can do with query complexity is assign a budget over time. So if you can identify the user or the customer through the access token, you can basically keep track of the scores of the documents over a specific period. And then if the total score for that period is exceeded, you can just automatically start rejecting any request that comes in from that access token until the period is over, which is basically GraphQL rate limiting. If you want to go deeper into that, there's also like a whole research going on about it from IBM. So yeah, check it out if you like. So how do we apply these measures? Like, how do we actually run them in our case? So we built like Hive Gateway for our customers to do federation, and it literally had already all these features. So we just reused it for our own purpose of now having a federation API for the public API. Yeah, was a no-brainer for us. So it basically has all these security methods that I just mentioned already built in. And on top of that, it can also do federation. So it also served for us as the schema contract server. And then in the future, we also want to use our new gateway that we just released, which is Hive Router, built on Rust. Yeah, we want to also in the future run our public API with that instead of Hive Gateway. And if you're interested in more about that, Camille and Dotan will give a talk about this, I think after this one. So, okay, now I'm almost at the end of my talk. So I talked about how we use GraphQL, why we decided to build a public GraphQL API, how we transformed our schema to get into that shape, and lately, last, how we protect it. So last question is, should you build your own public GraphQL API? And I say, it highly depends. Why? So GraphQL is very specific, right? Like, we all love GraphQL, but what I want to ask you is, like, do you already have a GraphQL API? We had in our case. We evaluated our users. They know GraphQL. They're in fact already using our private GraphQL API. And then after you evaluated your users, you also need to think about, like, am I up to like tackle these GraphQL specific challenges? Because I still think it's new land for a lot of people, and it's cool to share all this knowledge in order to see, like, how can we do it in reality. The last part is then also documentation. I did not mention that at all so far, but yeah, we have GraphQL. It gives you like an explorer of the GraphQL schema, but it still does not like give you a whole overview over the high-level operations you can do within your GraphQL schema. So you also need to like provide example GraphQL operations, like explain relations in the GraphQL schema. There's also something you need to think about. Okay, so I think we can still learn a lot about like building GraphQL APIs and especially like building public GraphQL APIs. And I want to thank you for being here. Do we have time for questions? 30 seconds. One question. Yes? Sorry, can you repeat?
MCP servers or any other documentation.
MCP.
Optimization.
What optimization? Sorry.
I mean, for the AI,
AI.
cursor or things like that.
We don't really use AI on our stack, so no. Sorry. Yeah, one more question.
You mentioned the problem with persistent documents from public API, but even for an internal API, one thing that like can be affected is like developer efficiency because you like it's a shift before you can just like write any queries, ship it, and you are good to go. Now there's this whole process of like
Hmm.
like kind of creating this hash for this query. How do you go about that? How can you keep like developer productivity using persistent documents?
So the question was like how do we keep the developer loop alive, like when you switch to persistent documents? The thing is, you don't use persistent documents while you're developing. You only use them when you're actually deploying. So on your development environment, you would just execute like arbitrary GraphQL documents. And then only in the build step, before you actually deploy to production or staging or quality, whatever, you extract those operations and publish them to schema registry or whatever, where they are then persisted, and then the GraphQL server actually loads the persisted operations from there in order to know which ones are allowed to be executed. Does that answer the question?
So staging and prod would be persisted, but dev not persisted.
Sorry?
So you would use persistent queries for staging and prod, but not for dev. Is that it?
Yes. So, yeah, technically. So, I mean, when we develop our stack, everything runs locally because we don't have like a highly distributed system, like at least when we develop, like everything runs on our machine locally. But like if you have like this scenario where you need to, from your development machine, call some other server, you need to come up with another solution on maybe you give access tokens that are allowed to execute arbitrary GraphQL operations to your developers or something like that. Does that answer? Okay, cool. Thank you.